Romex, also known as non-metallic sheathed cable, is generally prohibited for use in high-rise buildings above the third floor. This restriction is primarily due to fire safety concerns. High-rise buildings present unique challenges in terms of fire spread and evacuation, and the materials used in their construction must meet stringent fire resistance standards. Romex, while suitable for many residential applications, typically lacks the fire resistance properties required for high-rise construction. Building codes often specify the types of wiring methods permitted in high-rise structures, and these typically include metal conduit or cable with a metal sheath that provides a degree of fire protection. The specific requirements for wiring in high-rise buildings are outlined in the National Electrical Code, or NEC, and local building codes. These codes address various aspects of electrical safety, including wiring methods, overcurrent protection, grounding, and emergency systems. The NEC provides detailed guidelines for the selection and installation of wiring methods based on the occupancy, height, and construction type of the building. In high-rise buildings, the NEC typically requires the use of wiring methods that are enclosed in metal raceways or that have a fire-resistant rating. This is to prevent the spread of fire along electrical wiring and to ensure that critical circuits, such as those for fire alarms and emergency lighting, remain operational during a fire. There are several reasons why Romex is not typically permitted in high-rise buildings above the third floor. Firstly, Romex is made of combustible materials, including the plastic insulation and outer jacket. In a fire, these materials can contribute to the spread of flames and produce smoke and toxic gases. Secondly, Romex does not provide a barrier to the spread of fire. If a fire starts in one area of the building, it can easily spread along the Romex cable to other areas. Thirdly, Romex is not mechanically robust. It is easily damaged by physical impact, which can increase the risk of electrical shock and fire. In contrast, metal conduits and metal sheath cables provide a high degree of fire protection and mechanical protection. They are also more resistant to damage from rodents and other pests. The use of metal raceways also allows for easier access to wiring for maintenance and repairs. When selecting wiring methods for high-rise buildings, it is essential to consult the NEC and local building codes. These codes specify the types of wiring methods that are permitted for different applications. It is also important to consider the fire resistance rating of the wiring method. The fire resistance rating is a measure of how long the wiring method can withstand exposure to fire without failing. The NEC contains numerous articles and tables that provide detailed information on wiring methods and their applications. For example, Article 300.11 addresses securing and supporting wiring, and Article 310.15 covers ampacity ratings for conductors. Tables such as 310.16 provide ampacity values for various conductor sizes and insulation types. The restrictions on Romex in high-rise buildings are intended to protect the safety of building occupants and to prevent the spread of fire. By using appropriate wiring methods and following the NEC and local building codes, it is possible to ensure the electrical safety of high-rise buildings. The type of building construction is also a factor in determining the permissible wiring methods. Buildings are typically classified as either fire-resistive, non-combustible, or combustible construction. Fire-resistive construction is the most fire-resistant type of construction and is typically required for high-rise buildings. Non-combustible construction is less fire-resistant than fire-resistive construction, but is still suitable for many types of buildings. Combustible construction is the least fire-resistant type of construction and is typically used for smaller buildings. The NEC specifies different wiring methods for each type of construction. In fire-resistive construction, the NEC typically requires the use of metal conduit or metal sheath cables. In non-combustible construction, the NEC may permit the use of non-metallic conduit or cable, but only if it is installed in accordance with specific requirement. In combustible construction, the NEC typically permits the use of Romex, but only if it is installed in accordance with specific requirements. The specific requirements for Romex installation in combustible construction vary depending on the occupancy and use of the building. For example, Romex may be permitted in dwelling units, but it may be prohibited in commercial occupancies. The NEC also specifies requirements for the protection of Romex from physical damage. Romex must be protected from physical damage by being installed in a raceway or by being located in a protected area. The NEC also specifies requirements for the support of Romex. Romex must be supported at intervals not exceeding 4.5 feet. The NEC also specifies requirements for the termination of Romex. Romex must be terminated in a junction box or other enclosure that is listed for the purpose. The NEC also specifies requirements for the grounding of Romex. Romex must be grounded in accordance with Article 250 of the NEC. Article 250 provides detailed requirements for grounding and bonding electrical systems. Grounding is essential for electrical safety because it provides a low-impedance path for fault current to return to the source. This helps to prevent electrical shock and fire. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. The NEC also specifies requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overcurrent protection devices must be sized and installed in accordance with the NEC. The NEC also specifies requirements for wiring and hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dust. Wiring in hazardous locations must be installed in accordance with Article 500 of the NEC. Article 500 provides detailed requirements for wiring methods, equipment, and installation in hazardous locations. The NEC is a complex and comprehensive document. It is essential to consult the NEC and local building codes when designing and installing electrical systems. Failure to comply with the NEC and local building codes can result in electrical shock, fire, and other hazards. There are many resources available to help electricians and other professionals understand the NEC and local building codes. These resources include training courses, seminars, and publications. It is important to stay up to date on the latest changes to the NEC and local building codes. The NEC is revised every 3 years. The NEC is an essential tool for ensuring electrical safety. By following the NEC and local building codes, it is possible to design and install electrical systems that are safe and reliable. In summary, Romex is typically prohibited above the 3rd floor of high-rise buildings due to fire safety concerns. The NEC and local building codes specify the types of wiring methods that are permitted in high-rise structures. These codes address various aspects of electrical safety, including wiring methods, overcurrent protection, grounding, and emergency systems. It is essential to consult the NEC and local building codes when selecting wiring methods for high-rise buildings. The use of appropriate wiring methods and compliance with the NEC and local building codes are essential for ensuring the electrical safety of high-rise buildings. Remember to always consult with a qualified electrician or electrical engineer for specific guidance on electrical installations in high-rise buildings. The information provided here is for general educational purposes only and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it is important to take all necessary safety precautions.